This is what a stock S2000 engine looks like. And I like the idea of keeping everything looking stock. And if you have performance upgrades, it's cool to hide them. Look at what I got inside the airbox. That's an intercooler. That's that BMW intercooler I bought. And the output lines right up where the intake tube, there used to be an air filter here, and the intake lines up pretty good with where my charge pipes could come from the rear. Get some water into here, and obviously this hose can't hold pressure. I don't think it can hold 6 psi. Maybe it can, but you know, maybe we could run a pressure hose inside that or something, and actually use kind of high pressure hose inside the stock air intake hose. I think it'd be just really cool to have the whole thing be stealth. The question is this intercooler good enough? It came off a twin turbo I think a V8 BMW from like 2011, and there's two of them, one for each side of the engine. The engine was rated for 400 horsepower, so BMW used that to control 200 horsepower worth of air. And I'm looking at something a little over 300 horsepower. So is that intercooler undersized? It also comes with a sensor built into it. That'd be kind of cool. That's an integrated air temperature and boost pressure sensor. I've got the temperature part figured out, but I can't get it to register pressure. When I put voltage on the power pins and look at the pressure output, I get 2.5 volts. But doesn't change with pressure. If anybody knows more about these things, please leave me a message. So I kind of want to talk about the intercooler some today. Here's my current test setup. I've got the intercooler down there. I've got water going in it. I'm measuring the pressure above and below the intercooler. I'm measuring the temperature above and below the intercooler. I got a boost gauge that is a $13 Harbor Freight boost gauge. I don't totally trust it, so it may be a little bit off. Got the vest controller by Trampa. I got a switch that pre-charges automatically. I've got a little battery charger up here that stays hooked up to batteries all the time. I thought I had the perfect solution for the battery charger in the car, but this is not as great as I thought it was. This is a 12 volt boost converter, and I've got it right now boosting 12 volts up to 64 to keep the batteries charged. They rate this thing at 90 watts. They don't tell you that you don't get 90 watts with a 12 volt input, a 64 volt output. Actually, you get about 100 watts. So I'm not getting the current that I was hoping to get, which is too bad because I thought this was going to be perfect. But during my testing, that kind of keeps the batteries topped off. This is the data I got from that quick test. I was running this on 16 batteries in series. I'm going to run either 18 or 20, so it should get a little better than this. 5.5 pounds of boost. The temperature coming out of the air temperature out of the supercharger is 138 degrees. Seems a little bit low to me for that amount of boost. The temp out of the intercooler was 87, so it did a good job bringing it down. The water temperature going in was 74 and it came out at 87. The flow rate of 2 gallons per minute. I mean, obviously, if we got more flow, this is a pretty slow flow rate, the water wouldn't have heated up as much. It would come out colder and it had been more effective at reducing the temperature. But it worked pretty good anyway. If you noticed at 2 gallons a minute, if I just had 1 gallon of water in the system, it would take 30 seconds for that water to circulate all the way through the intercooler and back around if I just had 1 gallon of storage. So, having a heat exchanger out in front of the radiator isn't that important, because for short bursts of power, the water's never going to get around to that front intercooler. And I'm going to be using all cool water. And then you can have a few minutes for that water to circulate to get it cooled off again. Or we can go with a higher flow rate very easily and get this thing down, but I'll need a bit more water storage or a better front intercooler. So this summarizes the intercooler performance. The air was 57.5 degrees hotter than the water inside the intercooler, and it dropped that down 51 degrees, which is an 89% efficiency. So the best it can do would be to drop the air temperature down to the same temperature as the water, and I'm saying that's the average water temperature. And it did that within about 10 or 11%. Really pretty doggone good. And it had a pressure drop of 0.4 psi across it. So overall, I'm pretty pleased with that intercooler. This kind of shows what we might get from this setup. Once again, these numbers are not final or just estimates. But I summarize it without the intercooler, with the intercooler. And what if we had a perfect intercooler? I mean, how good is this intercooler? How much better could it be? Well, what we care about for the supercharger is the density of the air entering the engine. We want to get the most oxygen flowing to the engine as possible. And the more oxygen we have, the more fuel we can have, the more power we can have. So it's not so much boost pressure, it's density of the oxygen at the input of the engine. So what is the air density? Well, the pressure ratio at 5.5 pounds of boost, that's a 37% increase in air pressure over ambient. But air temperature also affects the density. Hot air is less dense than cold air. So without the intercooler, with that air temperature, we're going to lose 10% of that density due to the air temperature. So we don't get that number, we get the product of those two numbers. We get a 23% increase in the air density coming into the engine, which basically is a 23% increase in power. Now you add our intercooler to it, and we lose a little bit of pressure ratio because we lost 0.4 of a psi. But the air temperature ratio is much better. The intercooler dropped the air temperature down, and we end up with a 32% increase in air density at the engine input. And then what if you had a perfect intercooler? Well, the pressure ratio would be the same as without an intercooler because they had no pressure drop. The air temperature ratio would be a density ratio would be 1-to-1, right? Because the temperature would be the same as what was going in. And you'd get the full 37% increase in power. So here's some rough numbers. Without the intercooler, we can think about a 55 horsepower power increase. With that intercooler, probably 77. And with a perfect intercooler, 89. I think this intercooler is the fact that it fits in that magic spot in the old air box. I'm inclined to use it. If I could run more water through it, this number would go up a little bit, and then we're getting kind of close to a perfect intercooler. Now, some overall thoughts on these performance numbers. I think the 1-inch hole is flowing more air than this engine actually takes. So I think these numbers are probably low. I'm going to add more battery voltage. And the other thing to think is that this is only the numbers at maximum power. I'm going to show you the blower map in a second. And I think you'll see that the performance increase is going to be better than this at lower RPMs. Here's the blower map for the Rotrex C30. We had a pressure ratio of 1.35 or 37 or so, and the thing was, the impeller there was turning a little bit less than 60,000 RPM. And you can show that that's probably, we're flowing about this much air probably. I think the engine's going to actually need about this much air to get 330 to 350 horsepower. So I think this kind of shows that we were flowing a little bit more air than we had, which makes the numbers, the pressure and temperature numbers worse. But let's say we were operating right here at full throttle. And let's say that I set the supercharger to spin 60,000 RPM, which is about 6,000 RPM at the shaft. And you would see that as the engine RPM drop, the boost is going to go up. And this will be about 4,000 RPM here. This is probably going to be 8,000 or 9,000. 4,000 is going to be up here. And then once I get down to maybe 3,000, I don't want to hit the surge line. I'm going to start bringing the supercharger RPM down so that at low RPM, I'll follow a curve down like this. So some thoughts on kind of where I think this thing's headed. You know, the early electric superchargers like the torque amp, they were power limited. The motor did not have enough power to flow the air and the pressure at the same time that the engine needed. Corky Bell's got a great book, and I've got it. In fact, let me show it to you here. Excellent reference on superchargers. And he talks about the power that the electric motor needs is the airflow times the boost. And there's a constant in there. So the problem with the early, these other torque amp kind of guys, is that when you want, say, 6-7 pounds of boost, and once you hit a certain airflow, they just don't have enough power to keep pushing it. So they work great at low RPMs, but once you get a lot of airflow, the motor runs out of poop and the boost drops off. That is not my problem here. This motor has more power than I need. I think I'm using... I think that last test, I was probably in the 9,000 kilowatt range, 8 or 9 kilowatt range. The motor was probably putting out about 10, 11, 12 horsepower. This motor will do better than that. This motor could probably do 15, 16, 17 horsepower. So I'm not power limited, and the batteries are not power limited. My limitation right now is the speed controller, because it's a 100 volt input speed controller. And they say that's with peaks. So if I go 20S, that's like 80 something volts. Allow a little bit for peaks. I'm up close to the 100 volt max for that thing. My limitation is I can't get enough voltage on the motor to get the RPM higher. If I could put 100 volts on that motor, which that motor supposedly will take, then I could get the RPM up, and I got enough power to drive more boost. So right now, that's kind of where we are. And so the power of this guy is holding up pretty good, almost all the way to the max. But I am going to get more power at the lower RPMs, because if I run that 60,000 RPM propellant, it does give me more boost at lower RPMs. So that's it for today's video. I've got some other stuff I want to talk about. Next, I've got some more video to show. And then after that, we're going to start putting this thing in the car and seeing what happens. So that's it for today. We'll see you later.